This video is for section 3AT on exponent rules. First, we're going to review some of our rules of exponents. The first one is that any number to the 0th power is equal to 1, as long as the base, a, is not equal to 0. A to the negative n equals 1 over a to the n, as long as a is not 0. A to the m times a to the n equals a to the m plus n. A to the m over a to the n equals a to the m minus n, as long as a is not 0. A to the m all raised to the nth power is a to the m times n. A times b to the nth power is equal to a to the n times b to the n. A over b to the nth power equals a to the n over b to the n, as long as b is not 0, since we cannot divide by 0. A over b to the negative n is equal to b over a, so I flipped that fraction, to the positive n. And that's as long as a and b are both not 0. A to the 1 over n is the same as the nth root of a, as long as a is greater than 0. And a to the m over n is the nth root of a to the m for a greater than 0. So these should be review for you, these exponent rules, and what we're going to do is we're going to practice using them. So here are some practice problems. We want to use exponent rules to evaluate 3 over 4 to the negative third power. So the first thing I'm going to do is I'm going to use that rule that if we have a negative power, then I can flip the fraction and make it a positive power. So I'm going to rewrite this as 4 over 3 to the positive third power. Now I'll use the rule that says that if I have 4 over 3 to the third power, I can rewrite that as 4 to the third over 3 to the third. And now I can go ahead and evaluate that. I'm going to pull up my calculator. If I do 4 to the third to get the exponent, I use this up caret key. So 4 to the third, I'm going to hit enter, and 3 to the third. So I'm going to end up with 64 over 27. So that will be my response here, 64 over 27. So I've used my exponent rules to evaluate. And the work that I would show in doing that is exactly what I put here. So step by step, each exponent rule gets its own written step. Okay, next one, use exponent rules to rewrite the expression with positive exponents. We always want to have positive exponents whenever possible. I'm going to use the rule that says if I have 1 over x to the negative n, that is equal to x to the positive n. In this case, n is 2, so this is going to equal x squared. Now I have the 4th root of x to the 7th. I know that when I have a root, the number that is on the root or on the radical is going to be the denominator of the exponent. So this is going to equal to x to the 7 over 4, because x is raised to the 7th power and it's the 4th root. So that's x to the 7 over 4. Okay, so now we get a little more complicated. we're asked to multiply and simplify using exponent rules. So when I'm multiplying these expressions, what I'm going to do is look for the scalars, so the 3 times -4. So this is going to become 3 times -4. And then I look for the ones that have the same base. So this is, I'm going to rewrite the x to the 3rd and the x to the 6th next to each other. And I'm going to rewrite the y and the y to the 9th next to each other. Now these are multiplied together, and when I just have the y written there, it's like it's a y to the 1st power. So now I can go ahead and use my regular multiplication to do 3 times -4, so that's -12. This is going to be x to the 3 plus 6. So I'm using the exponent rule that when I'm multiplying, I add the exponents. And I'm going to have the same thing for y to the 1 plus 9. Now the reason that addition rule works when you have the same base is you think about x to the 3rd is x times x times x. So that's my x to the 3rd. X to the 6th is x multiplied by itself 6 times. So here's my x to the 6th. And so I really have 1, 2, 3, 4, 5, 6, 7, 8, 9 x's multiplied together. And so that's equal to x to the 9th. So that's why that addition rule works when you're multiplying the same base. So this is going to be -12, x to the 9th, y to the 10th. And that would be my final answer because I have positive exponents. I've combined all of the bases that I can, and I've multiplied my scalars together. Okay, I pulled out one problem from the homework that I often get a lot of questions on, and this is 3AT number 5. So this is number 5 from the homework, and it has multiple parts. It is rewriting radical notation as exponential notation. So the first 3 are fairly straightforward. Write each of the following expressions in simplified exponential form. So part A is the square root of x to the 5th. When there's nothing written right there, this is the square root. And the square root is a 2. So it's like I have a root with a 2 there. So this is going to be x to the 5/2. So as I said, that's pretty straightforward. B has the 9th root of x to the 5th. And so that's going to be x to the 5/9. C has the 7th root of x to the 5th. And so that will be x to the 5/7. So whatever your root is goes in the denominator of your exponent. Now part D and E are the ones that I get a lot of questions on. So what you are being asked to do by MyLabs Math is break this down into the most simplified version. So I have here the 25th root of 243 y to the 15th. Okay, so what I'm going to do first is I'm going to go ahead and figure out how to break down 243 as an exponent. So kind of over on the side, I'm going to go ahead and say 243 is equal to something to a power. And I'm going to play around with it. I know that 3 goes into 243. So 243 divided by 3 gives me 81. And I know that 81 is 9 times 9. So I'm going to go ahead and make a factor tree for this. So I'm going to say 243 divided by 3 is 81. I know that 81 is 9 times 9. And I know that 9 is 3 times 3. So if I look at all of the prime factors here of 243, I have 3, 3, 3, 3, and 3. So 243 is 3 to the 5th. And you could check that by doing 3 to the 5th in your calculator. So that's just kind of what you would do over on the side. You won't all have 243. You might have a different number in your version of the problem, but you want to break it down like that and use that to rewrite. So I'm going to rewrite this as the 25th root of 3 to the 5th times y to the 15th. Okay, now I can break that down further. That's equal to 3 to the 5 over 25, because remember the root goes in the denominator of the exponent, times y to the 15 over 25. Okay, I'm not quite done because those fractions can simplify. So if you're not sure how they simplify, put them in your calculator. 5 over 25, we know that's going to be 1/5, but if you're not sure, go to math. Number 1 is fraction, enter, enter. And then the other one, so that's 1/5. The other one, 15 over 25. So 15 over 25. We should be able to do that in our heads, but if not, go to math, fraction, enter, 3/5. So we're going to have 3 to the 1/5 and y to the 3/5. So 3 to the 1/5 and y to the 3/5. Now this is simplified as far as it can go because all of my bases are primes and all of my exponents are simplified fractions. And I have positive exponents. All right, part E, 243 times the 25th root of y to the 15. So 243 times the 25th root of y to the 15. Now we have already done the work for this. 243 is 3 to the 5th. We already figured that out above. Y to the 15 over 25 is y to the 3/5. We already figured out that as well. So this is going to be 3 to the 5th, y to the 3/5. And again, that was problem 5 on the homework for 3AT.